The final thing that we're going to talk about is El Nino and La Nina. And this represents episodes of anomalies in surface circulation of the ocean. It's an episode that occurs every roughly 3 to 8 years. And what we see is that during El Nino years, surface waters in the Pacific near the equator become warmer and the winds blow weaker than normal from the east. These are opposite phases of something known as El Nino Southern Oscillation. This is another term you might see that is used to describe it. And once again, as I said just previously, changes, fluctuations in temperature between the ocean and the atmosphere, typically in the east central equatorial Pacific. We don't see this happening in other locations on the planet, but just centered around the east central equatorial Pacific region, so off the coast of South America. El Nino in Spanish means the little boy or Christ child, and this name was used to describe this phenomena because it usually occurs around December when we see these warmer waters start to appear off the coast of South America. Originally recognized by fishermen in the 1600s when, once again, we had this warm water. It's a large-scale ocean atmospheric climate interaction, and it's believed to be linked to periodic warming of the sea surface temperatures. So we have something occurring in the sea. We also have something occurring in the atmosphere. The time range between when these happens varies. It occurs every 3 years to every 5 years, sometimes to every 8 years. And an El Nino episode can last typically between 9 to 12 months. What we see here is during normal times, if you look at the image on the upper top of the image on the right hand side, we see that, we have that typical South Pacific gyre moving colder water up from the pole towards the equator. This is colder water. We're going to have lots of nutrients associated with it. And we see that equatorial winds are blowing warm water westward. What happens, though, during an El Nino year is we see the situation actually flip around, not in terms of the ocean circulation patterns per se, but we see now that warmer, weaker winds now are moving warmer water towards the east. So instead of warmer water moving to the west, that warmer water moves to the east. This has implications in terms of the fishing industries along South America, and it also means that in North America, we tend to experience warmer winters. What happens during an El Nino year in comparison to a normal year? So in a normal year, and this is represented by the uppermost images on both the left and right hand side of the figure here, we see trade winds blow towards the west across the tropical Pacific, blowing away from South America. These winds tend to pile up warm surface water in the West Pacific, so sea surface there is usually about 0.3 to 0.6 meters higher offshore of Indonesia than across the Pacific. We also see that sea surface temperatures tend to be warmer in the west. So once again, the west of the ocean. The cooler temperatures dominate offshore of South America, and we see here upwelling of colder water from deeper levels, which really is nutrient rich and really helps support diverse marine ecosystems and major fisheries. Important because a lot of ports along this region depend on the fishing industry as their main means of a livelihood. Then for some reason, not entirely clear at this moment, but we see that these trade winds weaken, and they weaken in the central and western Pacific. Now what happens is because of the weakening of these trade winds, we see that the surface water temperatures of South America warm up. We have less upwelling of the cold water, temperatures of the water get warmer, we might see downwelling occurring, and we see that in the western tropical Pacific, this warmer water shifts eastward along the equator towards the coast of South America. Associated with this shift of warmer ocean waters, our clouds and rainstorms become intensified. So we have more clouds and rain and storms along the western coast of South America. What happens is warmer waters, they release so much energy. So these warmer waters that are now moving eastward release so much energy that it changes energy gets released into the atmosphere. You see weather changes that affect the whole entire planet. For example, we've already mentioned how you get warmer winters up in North America. Another slide just demonstrating what we were talking about in the previous slide. The other thing that we see with the shifting of winds, the shifting of ocean temperatures during an El Nino year, normally we see that there's an area of higher pressure sitting off of South America, lower pressure closer to Indonesia, warmer temperatures, water temperatures over in Indonesia, and then during an El Nino phase, we now go from higher pressures over Indonesia to lower pressures closer to the waters off of South America. and much, much warmer water throughout the whole entire ocean at this point. We also have La Nina, and La Nina is Spanish for little girl. And episodes of La Nina or La Nina episodes represent periods of below average sea surface temperature across the east central equatorial Pacific. Temperatures that sometimes be as low as 3 to 5 centimeters lower. La Nina appears approximately every 3 to 5 years, and this lasts a little bit longer quite often than the El Nino phases, anywhere from 1 to 2 years. After an El Nino phase, the climate will sometimes swing to a La Nina phase, but it doesn't always happen. So sometimes we'll have El Nino followed by La Nina, sometimes El Nino followed by just normal conditions that we experience most of the time. Why do El Nino and La Nina matter? Well, they matter because they both affect weather conditions globally. Depending on the length of time of an El Nino event, depending if a La Nina event occurs, we can see that it can affect the intensity of an event. It can affect where masses of warm and cold air sit, as well as warm and cold water. For example, if you look in the slide here, we see the jet stream. During episodes of El Nino, the jet stream, this is air moving from the poles. It sits more over central, the middle part, upper parts of Canada. During La Nina phases, this jet stream with cold air associated sweeps way down below into the southern parts of Canada, then up towards Nova Scotia. So with La Nina, we might have colder than average temperatures sweeping across Canada. We see that in other areas, for example, looking at this map here, this picture of the globe in North America, the American Southwest becomes, and most of the southern parts of the United States become quite dry during La Nina episodes. During El Nino, they can experience extended storm activity and storms that can sometimes have quite catastrophic results. Storms that result in flooding, landslides, and other natural disasters. Another look at some of the effects that El Nino and La Nina can have on the Earth's climate, on the Earth's weather patterns. Once again, I'm not going to ask you, what happens in Western Australia during June and August of an El Nino phase, but this is more here for you to take a look at and get a general sense of just how much these things that happen in that part of the Pacific Ocean can affect what happens globally. Not only does El Nino and La Nina have effects in terms of climate patterns, weather patterns, but we see a lot of other economic consequences. It has an effect economically. It can affect agriculture. You can imagine that in parts of the U.S. that grow crops, if you have a dry season due to La Nina, this is going to affect your ability to earn money through selling your crops. It definitely affects the fishing industry along the west coast of South America. Once again, this upwelling that tends to bring nutrients up to the surface disappears, and now we have nutrient poor water, and the fish stocks reflect this. Energy. If you're in a place where we rely on hydroelectrical energy, let's say, for example, California, lots of rivers and streams there. These are tapped for hydroelectrical power. If we experience a period of drought, we no longer have that water moving through the system to create energy. Same thing for electricity. Real estate values can be affected by this El Nino in a number of different ways. Once again, you want to sell a vacation property. If it's a cold, wet summer as a result of El Nino, you're probably not going to sell that property. And tying in with that, tourism as well. Finally, insurance. El Nino can bring an increased impact of storm activity. This can result in an increased number of insurance claims at different locations throughout the world. Another thing that we see, La Nina events tend to increase the number of hurricanes that hit, especially in North America. So if we have a La Nina phase, we can expect that during the subsequent hurricane season, we're going to see a lot more hurricanes. So the potential is going to exist there for a lot more hurricanes to occur. And as you've already figured out probably from previous slides, the intensity and the incident rate of natural hazards also increases. We see landslides being triggered, we see tornadoes being triggered, flooding in all locations of the world. So once again, this switch in climatic and circulation patterns, both in the atmosphere and the ocean, has far-ranging effects. Due to the fact that El Nino and La Nina can have tremendous impact on global climate and weather patterns, it can impact global economic resources, the global economy, as well as create conditions for a number of different disastrous natural hazards. What we see is that there is a lot of work in going into predicting when the next El Nino and La Nina phase is going to occur. So currently, in the fall of, or in the spring of this year, February of 2019, the World Meteorological Organization issued an update and predicted there is about a 50 to 60% chance of El Nino occurring within the next 3 months. They do this by tracking sea surface temperatures, looking for changes in sea surface temperature, long range changes in sea surface temperature, and use both physical and statistical modeling. They throw a whole bunch of numbers into a program and they come up with a model that says, yeah, this is, what likelihood there is that El Nino might occur. This is now the end of this module. Once again, any questions, feel free to contact me. Thanks again.